Hi everybody, welcome back to the section 2.3 video. In this video, we're going to turn our attention to solving an initial value problem. Still a linear differential equation, but we have an initial condition now that we would need to use to find what our constant C would be at the end. But still a linear equation, so we're still going to uh, tackle this how we normally would. So first step is always making sure that our dy over dx is by itself. So step zero, um, get dy over dx naked, but it's already in standard form. So dy over dx already naked. Okay, so it's already naked, so we don't need to divide anything. So that means that I need to calculate my integrating factor now. So my integrating factor, mu, is e to the integral of p of x dx. Well, what is p of x? So we just have y here, but it's like an invisible 1 times y. So that means p of x is just going to be 1. Okay, so that's going to be my p of x function. It's just going to be 1. So pretty easy to work with. So it's just going to be the integral of 1 dx, which is just means dx, which is just e to the x. So this is my integrating factor mu. Okay, step 2, we take this mu and multiply it both sides. So what I would have is e to the x times dy over dx plus y equals x times e to the x. And if we distribute this in, what we get is e to the x times dy over dx plus e to the x times y equals x e to the x. Okay, so remember we want to, when we multiply by the integrating factor, we want to recognize that this equation now is the derivative of some product. And so this one's a bit easier to see that e to the x is f, e to the x is f prime, dy over dx is g prime, and y is just g. So what I get is the derivative of the product e to the x times y equals x e to the x. Okay, so step 3, we want to integrate this. And so we'll take the integral of d over dx, e to the x times y equals x e to the x. We're going to integrate this. The integral and derivative cancels out, so I'm left with e to the x times y. And, we could go through this and integrate by parts x times e to the x. But, we previously showed in example 2 that the integral of x e to the x is just x e to the x minus e to the x plus c. So we can just use that information and continue on with our problem. Okay, so now we want to clear out, we want to solve for y, so we'll divide both sides by e to the x. And so things will start canceling out. So e to the x cancels out. That e to the x cancels out. And so I'm left with y equals x minus 1 plus c over e to the x. And now what we want to do is use our initial condition, and that's y of 0 equals 4. So we're going to plug that in. So it'll be 4 equals 0 minus 1 plus c over e to the 0. And that becomes 4 equals negative 1 plus c over 1, which is just c. But if I add negative 1 to both sides, this will just be 5. So my constant is just 5. Go ahead and plug that back into my c. But therefore, y equals x minus 1 plus 5 over e to the x. And that's my answer. Okay, so that is an initial value problem for a linear differential equation. So there's one more example to go over, but this one's a bit familiar. This linear equation dy over dx minus 3y equals 0. It's familiar to something we did already in this section. So here's what I want you to do is you try it out. So I want you to pause the video, give it a try, and then I'll post a solution. You could verify your answer. But pause the video, try it out, and then we'll be right back. Okay, welcome back. So hopefully you try this problem out, and whether you got to the end or maybe got stuck along the end, hopefully you at least follow the same steps. But this is pretty similar to something we did earlier in this section. So step 0, see if it's naked. dy over dx is naked. It already is, already in standard form, so we don't need to clear anything out. So what we can do is step 1 is just get our integrating factor. So we calculate e raised to the integral of negative 3 dx, and we get e to the negative 3x. In step 2, we multiply e to the negative 3x to both sides, and we can recognize that we're going to have a product of a derivative. And so we can write it as d over dx, e to the negative 3x times y equals 0. And so we take the integral of this setup. And here's maybe you got a little stuck just in case. It's very uncommon, but we integrate both sides and we integrate 0. And the integral of 0 is a little uncommon that we do that. But what we get is actually a constant. And so we get a constant, then we isolate y, and we get c e to the 3x. And that's our answer. Okay, so hopefully you got this answer, or at least you got close, but make sure you're following the same steps and method. But that's it for linear differential equations and the method to solve them. That's it for this video, and I'll see you in the next one. Okay, take care.